Hello everyone, welcome back to the channel. This is part 4 of a video series where I'm attempting to explain every Sudoku solve technique. In parts 1 through 3, I covered basic techniques, advanced groups, and fish respectively, so make sure to check those out. There'll be a link to those in the description. As always, we're going to be using Sudoku Coach to generate the grids for this video, and special thanks to Yen from Sudoku Coach, who taught me how to enable some features that'll make the notation a lot easier to follow, so that's been really helpful in making this video. Anyway, in the last part, we covered fish techniques. And one of the main appeals of fish techniques is they are only focused on a single digit, which can make them a lot easier to see, especially with the basic fish, which have kind of an intuitive pattern. But as we got further and further into the video and covered advanced fish with all of the different mutations that they have, a lot of these fish became harder and harder to pull off for kind of diminishing returns. With the basic fish, you could eliminate several candidates at the same time, but with some of the mutant fish, especially the finned ones, you can really only make one or two eliminations, despite the technique being so much harder to pull off. So in this part, we're going to cover another single digit technique that can replicate a lot of those same eliminations using, in my opinion, a much more intuitive logic. And those techniques are called single digit chains. So let's get into it. So chains in Sudoku are all about examining the relationships between candidates, or in other words, how candidates are linked. And there are really two links that we're concerned about, and those are called weak links and strong links. Weak links basically say that if a candidate is true, everything it is weakly linked to must be false. So let's go ahead and take a look of an example where that happens. Here I just have one of the puzzles in the campaign of Sudoku Coach. And let's go ahead and focus on the digit of 2. We could say, for example, that this 2 in row 4, column 9 is weakly linked, and we're going to go ahead and represent those weak links with a dashed blue line, to this 2 in row 4, column 2. And that's because if we were to say this cell right here is a 2, then this cell right here could not be a 2 because it's in the same row. And, we could say that vice versa about if this cell were a 2. So generally, we could say that for candidates of a single digit, that they are weakly linked to every other candidate in the same house, whether that's candidates in the same row, box, or column. So this 2 right here is going to be weakly linked to this 2, this 2, this 2, this 2, and this 2. So weak links are pretty common. So the other kind of link we care about is strong links. And these essentially say the opposite of weak links. They basically say that if one candidate is false, every candidate it's strongly linked to is true. And if we're only focusing on a single candidate, the only case where this happens directly is with buy local candidates. And that's because if there's only 2 options for where a digit can go in a house, if it's not one of those options, it must be the other, because the digit has to appear exactly once in each house. So because of this, strong links are a lot rarer than weak links. So let's look at some examples of what strong links look like. Let's go back to our 2s again. And we're going to go ahead and represent our strong links here with a solid red line. So we could say that this 2 is strongly linked to this 2 because they are buy local in that column. This 2 is strongly linked to this 2 because they're buy local in this box. And this 2 is also strongly linked to this 2 because they're buy local in this row. And we could also see if this 2 was true, all of these that it's strongly linked to would be false. So for all these cases of a direct strong link, we could say that they're also weakly linked. So if this 2 is false, all 3 of these candidates it's strongly linked to must be true because of the strong link. And additionally, it's weakly linked. So we could say if this candidate is true, all of the candidates it's strongly linked to are also going to be false. So that is the strong link. And what we could do is we can combine our strong links and weak links and chain candidates together to get certain implications and cause some eliminations. So let's look at some examples of where that happens. So alternating inference chains, or AICs, jump from one candidate to the next, alternating between strong and weak links, and they have to start and end on a strong link. So AICs aren't necessarily a single digit technique. We're going to see tons of examples of multi-digit AICs in future video parts. But all of the examples we'll cover in this part are going to be types of AICs. So I wanted to get the concept out of the way early. But yeah, let's go ahead and look at an example of how an AIC can work. This is a grid from Sudoku9981.com, and our candidate of importance here is threes. So this is our chain right here. You can see it's alternating between the solid red strong links and the dashed blue weak links. And let's go ahead and examine the implications if we were to start at one end of the chain. So let's say, for example, if we start at this end and we make this three right here, we say it's false. So three is not the true candidate to be placed in this cell. We could say if this three was false because of the strong link, this three must be true. And then because this three is weakly linked to this three, we could say this three must be false. And because that is strongly linked, we could say the strongly linked three must be true. So hopefully you can kind of see the logic behind why we would want to alternate between strong and weak links, because you can go ahead and do a false, true chain. So if we were to kind of continue that logic, if this three is true, the weakly linked three must be false. And then finally, the strongly linked three at the end of the chain must be true. So we started with a false three and we ended with a true three on the other end. So let's go through and see what implications we get if we do it from the other direction. Let's say we start with this three as false. Because of the strong link, this three must be true. And then we go false, true, false, true. By the time we get to the other end, this three is true. So no matter what we do, one end of this chain, the three is going to be true, which means that we could eliminate any candidates that see both ends of this chain. And the only candidate that does is the three in this cell right here. So we can go ahead and eliminate that three there. And that is the basics of AICs. Skyscrapers are a type of short AIC with only three links, where both strong links are either rows or columns. So here we have a grid from Hodoku, and our candidate of interest here is going to be ones. So we could see that we have strong links between our ones in this column as they're bilocal, and we have a weak link between these ones. These ones in this row are also bilocal, and we could use a strong link instead, but for the purposes of the AIC, we will treat this as a weak link, which it is. And finally, we have our strongly linked ones in this column. So that's kind of the structure of the AIC, and you can see just by looking at it why it's called skyscrapers. These two strong links kind of look like towers, and just like towers, in order to stand up, the links must be strong. And both of these towers share the same foundation, which is this weak link right here. So because of that, skyscrapers, pretty easy to remember, pretty easy to spot, and we can make the eliminations which see both ends of the skyscraper. In this case, there are 4 cells which we could eliminate from. And these are the cells I have highlighted here. I can go and eliminate the ones from all of those. Here's another example of skyscrapers from Hodoku as well. In this case, our candidate is a 4, and the strong links are rows instead of columns. So this is the exact same from a logical perspective, although the skyscraper analogy doesn't really work as well when it's horizontal instead of vertical. But we could see we have a strong link, bilocal 4s here, and then this 4 is weakly linked to this other 4 in the same column, and then we also have the strong link of bilocal 4s in this row. And there's one candidate that sees both ends of this chain, and that is this 4 right here, so we can go ahead and eliminate that. So that's another example of a skyscraper. So a cool thing about skyscrapers is they actually have the exact same structure as sashimi X-wings, which you can recall from the last part on fish. And this is because we have a pair of bilocal cells, and while they don't line up in the columns exactly, they still see candidates in the same box. So we can make the same eliminations as we would using a sashimi X-wing and replicate those with doing chains, if you're not in the mood for looking for base sets and cover sets like we would with the logic of fish. Two-string kites are another 3-link AIC, but this time one of the strong links is a row and the other one is a column. So we have another grid from Hodoku here, and our candidate is going to be a 1. So as we can see, we have a strong link in this first row, strong link in this first column, and they're connected through a weak link in this box here. So the only cell that sees both ends of this chain is this one right here. So we can go ahead and eliminate it. And you can kind of see why this is called a two-string kite. It kind of looks like someone is holding up a kite, and they have the string here, and the kite is actually here. And one way you can remember this is that in order to hold on to the kite, you have to be strong. So you have to make sure you're holding onto it strongly. And the kite itself has to be strong. But in order to flap around in the wind, you could have a weak link between yourself and the actual kite. So that is the two-string kite. Cranes are the last type of short AIC we'll cover, and these occur when we have one strong link is either a row or column, and the other strong link is within a box. So we have another grid from Hodoku here, and our candidate of interest is a 5. So we could see we have a strong link of 5s in this row. We have this 5 is weakly linked here, and then finally a strong link in this box. And the only candidate that sees both ends of this chain is this 5 right here. So we can go and eliminate it. And if you want to remember the crane, you could say that in order for a crane to stand up, it's got to have strong legs. That's what you could say this row is for. And it's also, if you need to hold anything up, you got to have a strong beak, or if it's a crane, construction crane, you got to have a strong arm to that crane. So that's how you can remember the crane. So we've looked at a lot of shorter single-digit chains, which are relatively easy to spot based on their patterns. But here we're going to go over how we could spot longer single-digit chains. So these chains are typically called X chains, and that word's basically synonymous with single-digit AIC. And there's a couple of tips we could use to actually help find those X chains. So here we have a grid from Sudoku Coach's lesson on X chains, which lays out a really nice process for actually finding these. So we're going to go through and look at each of our different candidates and their placements and see if we can make any X chains out of them. So let's just go through each of the candidates. With our ones, there really isn't anything interesting going on. There's only 4 candidates there. With our twos, a little bit more happening, but this pattern also is not too interesting. You can't make any eliminations from this. And really, looking at these different candidates is more of an art than an exact science. You kind of build up an intuition for what candidate placements look like they make sense and which ones maybe warrant a little bit more investigation. Threes are already filled in, so nothing to see there. Fours, it's the same pattern as the twos. Nothing too interesting. Fives, there's a little bit there's a little bit of interest there, but let's go ahead and keep going. Sixes, the same pattern as the twos and fours. Sevens also could be pretty interesting. Eights are filled in, and nines, we just got 2 X-wing like patterns here, so nothing to see there. Let's go back to sevens. What we really want to do when we're finding chains is we want to look for the rarer of the 2 links, which is our strong links. And we could go through and identify all those strong links pretty easily by just going column by column, row by row, and box by box, looking for bilocals. So let's start just going row by row, see if there's any bilocals here. There appears to be in this row, row 5, there's a bilocal here. Row 6, there's a bilocal here. And row 7, there's a bilocal here. Now let's go to the columns. We got strong link there, strong link here, quite a few strong links. And then finally, let's go through the boxes. We have a strong link here, strong link here, and a strong link here. And so that is going to be all of our strong links for our sevens in our grid. And what we want to do is just look if we can make any eliminations based solely off of these strong links. And it doesn't look like we can. The only case in which we'd be able to, all of these strong links are 4 links long. So the only case we'd be able to is if we had a candidate that saw 2 nodes on one of these, strong link loops we have here. And we don't have any candidates that meet that criteria. So those strong links by themselves can't find, any eliminations. But we could actually see these 2 clusters of strong links we have here can be linked up by a weak link. And that's going to be important to the chain because we couldn't find anything with the strong links themselves. So based on the placement of the weak link, and since we know that we have to have alternating inference, so we have to go from strong to weak and back, We could say that any links that are adjacent to our weak link must behave as strong links. So for example, this link right here is adjacent to our weak link, and this link right here is adjacent to our weak link. And again, by the rules of AIC, any links adjacent to those must behave as weak links, which includes this link here and this link here. And again, they're all bilocal, so they can behave as either strong or weak links, depending on the needs of our chain. So let's go ahead and rewrite those as weak links. Now, if you look, we have two adjacent weak links, which we can't have in an AIC. And suppose we were to start on this candidate, well, the only place it can go is to another 7 using a weak link. So this is not going to be a valid candidate to start or end our AIC. Therefore, we're really not going to pay attention to this candidate or its links. Let's look at our other node that we cluster of strong links we have here. So we have our weak link, and therefore this must behave as a strong link. Therefore, these two links must both behave as weak links. So we're going to go ahead and rewrite those. This remains as a strong link, whereas these two both turn into weak links. And you'll notice both of these two weak links end up leading to the same place, which is this 7 right here. So let's go ahead and highlight all of the candidates that our chain can start or end on. So it can be this candidate here, this candidate here, this candidate here, or this candidate here. And let's go ahead and test out all of our different combinations. So first, starting with this candidate, we go strong, weak, strong, and ending here. We have no cells that see both of these 7s, so we can't make any eliminations from that. Let's try it again, going 2 links further, strong, weak, strong, weak, strong. We have no cells that see both of these nodes, so no eliminations can come from that. Therefore, nothing is going to come from this 7 right here. We can go and stop analyzing it. Let's try this 7, strong, weak, strong. Nothing sees both instances of it, so we can't say anything about it. And then we can go strong, weak, strong, weak, strong. And here we have an interesting elimination because we actually do have a candidate that sees both nodes here. And that's this 7 right here. We can go and eliminate that. So that is the process for actually finding these longer X chains. So sometimes when we're looking at X chains, we'll run into situations where the links between individual candidates don't give us any useful information. But if we analyze groups of candidates and the relationships between those groups, we can make eliminations. And this technique is called group AIC, or in the case of a single digit chain, it would be called group X chains. And this is possible because when you have candidates that share both a box and a line, um, you could have 2 or 3 candidates with the exact same link structure. One of those links could be within the box, and one of those links can be on the line. And because of that, you could treat those 2 or 3 candidates as a group instead of looking at each of those candidates individually. So here I have a grid from the Sudoku wiki, which has a couple of nice examples of how we could perform those group AICs, or in this case, group X chains. And the candidate we're interested in here is 8. So looking at where all the 8s are on this grid, it doesn't look like there's a ton of useful information. We have a couple strong links, these 2 8s, these 2 8s, and these 2 8s. But besides that, there really isn't much to go off of here if we are just looking at it from the perspective of regular individual candidate X chains. But let's look at what we can do when we bring groups into the mix. So we could look at this strong link right here. That is a strong link between individual candidates, so nothing new there. And we could say this 8 is weakly linked to this 8, also nothing new there. But here we could do something interesting. So this 8 in this box shares the box with these 3 other 8s, which lie on the same line. So we could treat this as a group. And I want to go ahead and draw that group out in blue here. We can go ahead and treat this as a group. And we know if this 8 here isn't true, one of these 3/8 must be true. So what we can say is that if this 8 is false, this group must be true. Therefore, this is a strong link. This 8, individual candidate of 8, is strongly linked to this group of 3/8. Now, let's take a look at this group of 3/8. All three of these 8s see all the candidates on the same line, which includes both of these 8s. So we're going to go ahead and draw these 8s in yellow. And what we could say is this blue group is weakly linked to this yellow group. Because if any of these 8s are true, then none of the 8s that would be in this yellow group could be true. We could also say it's strongly linked because if all of these 8s are false, then one of these 8s must be true. But because of the rules of AIC here, we have to treat this as a weak link, which it is. And then for our final link, we could say that this group of 8s is strongly linked to this group of 8s, right? Because if the 8s in this row and box can't be true, then the 8s in this column and box must be true. So we could say there's a strong link between these two groups right here. And let me go ahead and highlight that other group here. I'll go ahead and highlight it in red. It would be this group of 2/8. There would be a strong link between this yellow and this red group. And what we could say from that is this beginning part of the chain, this individual 8, and this red group of 8s both see these 2/8 right here. So therefore, we can go ahead and eliminate both of these 8s because they see both ends of the chain. So with group links, you could link groups to groups and individual candidates to groups. We see a group to group link here, a group to group link here, and a candidate to group link here. So there's a lot of different possibilities with these, but there is a very important caveat that we have to go over with groups, and that is strong links between groups don't necessarily imply weak links. So in this specific case of the yellow and red group, the strong link is also a weak link because if either of these 2/8 was true, both of these 2/8 would have to be false. And that's because they don't share any candidates. They're two disjoint groups. But if we were to put an 8 in this cell right here, then this strong link wouldn't necessarily imply a weak link because if all three of these 8s were false, then one of these 8s must be true. So the strong link still holds. But if one of these 3/8s is true, that doesn't necessarily mean that all these 3/8s are false. And that's because an 8 can be in the intersection of both groups, and therefore both groups could be true at the same time. So strong links don't necessarily imply weak links for the case of links between groups. But anyway, that is how you do group AICs or X-chains. The empty rectangle is a short chain technique with only 2 links that essentially forces a contradiction by emptying out a certain box of all of its candidates. And I have a grid here from Hodoku to demonstrate that concept. The candidate we're going to be focusing on, or the digit we're going to be focusing on, is a 1. So let me go and highlight those 1s. And in order to perform the empty rectangle, we have to look at a box where our candidates are confined to one row and one column. So let's take a look at this central box. You could see that all of our candidates lie in this row and this column. This is very important for actually performing our empty rectangle technique. Now, the trick with the empty rectangle is first you have to look for a strong link that sees either the row or column, and connected to that strong link, we have to find a weak link that sees the other row or column. So, for example, if our strong link sees our column, then our weak link must see our row. And we could actually demonstrate that here. We have this strong link between these two 1s sees our column, and this 1 is weakly linked to this one right here, which sees our row. And what we can conclude from this is if this 1 was true, this 1 would have to be false, which makes this 1 true. Both ends would be true, which is impossible because then there wouldn't be any room left for 1 in this box. So from that, we could say this 1 has to be false. Now, you may be thinking, okay, pretty useful technique, but I thought this video was just going to cover AIC techniques. And you would be right, because even though this specific way to explain it doesn't start and end on a strong link, it is still an AIC. We just have to frame it differently. So let's look at this again, but from the perspective of grouped X chains. So what we could say is, let's go back to this middle box here. We could say we have two groups, one in our row, which I'm going to do in blue, and one in our column, which I'm going to go ahead and do in yellow. And these two groups contain all of our candidates. So they must be strongly linked, because if one's false, it has to be in the other. It can't be outside of those two groups. So this blue group is strongly linked to this yellow group. Then we could say this yellow group, they all see this one right here. So we could say that yellow group is weakly linked to this one. And then finally, we can go back to our strong link we use in the empty rectangle technique and fill in that link. So what you'll see from this is we have a group AIC where this blue group is strongly linked to this yellow group is weakly linked to this one, and this one is strongly linked to this one right here. And our candidate of one in this cell sees both ends of our group AIC, and therefore we could eliminate it. And logically, this is identical to the original explanation of empty rectangles, but this is just a way to demonstrate the same technique through group AIC, which I think really shows the power of our group AIC technique. And with that, we conclude this part on single-digit chains. Make sure to leave a like if you enjoyed the video, and leave a comment if you have any questions or suggestions. We will be continuing this series with the next part focusing on multi-digit chains and wings. So if you want to stay tuned for that, make sure to subscribe. In the meantime, thanks for watching.